Hello, everyone. Welcome to Mobile Theater. My name is Igor Andersov. I work at BISC Education, where we believe in bringing innovative learning solutions online to better lives of millions of people around the world. And today, I'll be talking to you about this methodology that helps us to build a mobile exciting solutions. It's called 12-factor apps. Now, I'd like to see a show of hands who've never heard of 12-factor apps. The rest of you have. OK, so we'll be learning something. And how many of you have never done anything with Heroku, like developed anything on it and built? So quite a bit of you will be learning something here, so it's good. So now, most exciting slide of the day, our safe harbor slide. I'm sure we haven't seen that before. Just a reminder to base your buying decisions, not what you see on these slides and not what I'm talking, but really what's available today at Salesforce. So let's begin our journey. Oops. Having a little trouble here. OK. Maybe I won't use that. So we have customers that bring all kinds of great ideas to us, and we're sometimes overwhelmed with requests and requirements and all kinds of things that's thrown at us at one time. And today I want to introduce to you this 12-factor app methodology in a set of tools aligned together with Heroku and Salesforce, how we can solve that problem to bring these innovative technologies for people around the world and make it mobile for massive scale. So let's join on the story, and let's assume that we are here as developers, and we've been charged with this task from a customer to build a mobile app. And they have this great idea, they just don't know how to make it, right? How do you bring that app to the App Store? And we have some group of people that may be doing development in mobile. Some of them are potentially API developers. Some of them are Salesforce admins. And so we're all going to be joining in this journey and learning how we collaborate and work together to make this work. Right? So how do we actually make sort of this disjoint ideas, massive amounts of agile stories, and various requirements that flowing onto us into organized engineering project? And I would present to you as 12-factor apps is one of the methods of doing that, by going through incremental steps to work through that process. And we have, on our journey, a customer that is a farming company. They have never built an app, but they had a great idea. They gave us this charge. Well, let's build it. And they had some designs in mind. They had some functionalities that they wanted to include in the app. And so we start working on it. We assemble our team, which all of us here. And I see so many faces from different cultures, different parts of the world. And let's assume we all go home and start developing and working on it remotely. So how do we collaborate on that, right? So speaking various languages could be a challenging aspect. So first, we begin with a set of tools. So that's stuff that we'll be working with to actually implement our app. We have Salesforce. We got Heroku Enterprise. We're using Heroku Connect, and also Postgres database. And our API will be having our API developers building with JavaScript, Node.js, and using Swaeger for the documentation. A mobile team will be going along with the UX group and building out iOS application in Swift. And we'll be using the modern Swift 3 and Xcode 8. Why not? We're at Dreamforce, so use latest and greatest, even though it just came out before the conference. So we start with a journey to build an API. And Swaeger is a popular API design tool where we can quickly iterate and build APIs and test them out in live environment as mock data, and then connect it to actual real data. The advantages of using something like Swaeger or other tools that allow you to do that is declarative way to build your API or design your API using something like a JSON or YAML files. And basically, you can create that very quickly and iterate on that design. Not only that, Swaeger has an add-on benefit that it provides a live documentation based on that specification so that we all can share the same information. So our Salesforce group can use that to build their models. Our developers on mobile side can map out their process and their screens, as well as our API designers could continue mapping out that to Salesforce tables. Swaeger isn't the only tool. Obviously, there's other options like Apiary and Apigee and some other tools available as well. But they all really follow the same format, either RAML or YAML. They're all open standards. And here we have an example. So let's jump in a quick demo of this. Oh. I guess I have to get out. Yeah, that's what happens without testing. Just bear with me for a minute. I'm going to jump into my Swaeger editor. Now, while that's coming up, it takes a little while in development. I had a little bit of an issue here with another browser. So when Swaeger comes up, we'll see an editor that allows us to quickly build an API and also generate code from it in a number of different languages, which in our case, we'll be looking at the Node.js, but it also can generate various other languages. So here we are. So you notice that on this side, we have actual design tool where we can build our YAML file. On this side, we have our harvester API on Heroku that we will be working with. All right, so I'm going to pay attention to just one thing. As I mentioned, our customer is a harvest kind of a processing plant, and they accept various types of products. Let's say, for example, sugarcane or rice harvesting all need processing. So farmers will bring in these loads, and there's an interaction going on between the farming community and this processing plant for a daily quota. And we're going to look at the quota API as our sort of a demo path as we're going to go through developing that in the process, right? So we're looking at our quota, how we designed this here, and we're going to go ahead and generate this. Pick one of the languages, Node.js. And so we've just generated a server API based on this YAML file. Now, if I go to now it's there. If I go to an example of that, that's kind of what it looks like. We have our index Node.js that's been generated for us. It's already have a harnessed, everything wired up, and with some sample data. We're going to try to see. No, I'm not there. Just want to try to orient myself where I'm at. So we're going to go to take a look and see how that actually works. So here's our Node.js server generated code. If I could highlight it well. Right, that's what we saw. We do index.js. And now we have a server running locally on our machine. So what that gives us is we can actually go and hit our local server, and we have API running live in a few minutes. Now, not only that, an added benefit of that is we can also change this to a localhost docs. At that point, we have documentation. Now we can share and collaborate on our API for our mobile app, while other teams are progressing further. So let's go back to our presentation. Right, so we've designed an API. We looked at what we've got there. We have it sort of working. Let's look at what the 12 factors are and how we work. One thing I forgot to mention is that as we collaborate in the process with multiple developers across the world, the first step we actually do is set up a repository in GitHub or some other type of source control system so that we can all share and merge code together. And we can work on multiple projects that way. So here's 12 factors. You don't have to memorize them all. We will be looking at each one of them quickly. Just a quick note, a 12-factor app methodology was developed or put together by Adam Wiggins, who is a co-founder of Heroku. A few years ago, he published that as one of the methodologies of his experiences while they were building Heroku platform. So let's dive in. Factor number one, we have code base. And I mentioned we're setting up GitHub for our repository. In our case, worked well for us. But it's not limited to that. You can use any SVN repository. The only sort of a thing to keep in mind is you want to keep one-to-one relationship, one repository, one code base, one app. You don't want multiple apps sharing code bases. This gets complicated. So it's very simple one-to-one relationship. If you want to share code, create a shared library or utilities or framework in the case of mobile application. And factor number two, we got dependencies. Every project has dependencies of some sort. And for us, we're using Node. So we've got some Node dependencies for server API. We've got some dependencies on Xcode. Automate that as much as possible. Use some type of package management system. Under Node, we have a wonderful NPM that helps us to do that. And in Xcode, you got CocoaPods or Carthage or some other type of tools that there are many number of tools that are available for that. Number three, configuration. These things are something that changes with environment, right? You want to keep your configuration with the environment because we will have, in a typical enterprise application, we will usually have a production system, a development system, a staging system, or QA system. And you want each one of these configurations to stay with the system as you migrate your code base and promote it to different environment to test. So that the code doesn't change, but the configuration is what changes. And under Heroku, you have environment variables that very easily enable you to do that. And with Xcode, you got build targets and to provide that ability with plists as well as schemes. Number four, backend services. Think of it as any database, any API, any service that you're going to access externally as your backend service, and treat them as URL endpoint. It makes your architecture much simpler and robust. And things like, for example, Heroku, with Heroku, we will think of add-ons, could be a backend services, or AWS S3 and databases as well. Salesforce would be another example of a backend service. Our mobile API, the REST API that we develop is the backend service for our mobile. And number five, build, release, and run. Strictly separate them and just follow your framework that you've chosen. Number six, process. Under Heroku, the processes are executed in a dyno. A dyno is essentially a virtual unit, a Linux container that shares nothing. So architect your application in such a way that you can run one or more processes, atomic operations or applications that are stateless. Port binding at number 7 is export services via port binding that enables you to basically, we have API, we have web applications that always connected to the internet of some sort, so we always need to have a port. Here we have also a quick example of configuration where we're binding a port and providing a default of 8080 as you saw local environment. So this is, we're getting a port from a Heroku environment or a local environment if we had that a variable defined. And over here, we're binding with Node.js, creating a server and binding to the port. Concurrency is number 8. It goes kind of a little bit with processes. I want to stop here for a minute and just kind of explain a little bit. The dynos are individual virtual machine where you run your application. But within that virtual machine, you could actually run multiple processes. Depending on the language you choose, and depending on a framework you use, it will vary. In our case, we've chosen Node. And Node has some inherent architecture dependencies. They're limited in scale, because Node is a single-threaded system. And so to scale it, Node provides something called clustering API. We've chosen not to use clustering API, but rather one of the abstractions on top of that API called Throng. And this is a code example how you would wrap the same code that we just generated right here into this start function. And then we define a variable here for the concurrency that enables us to do what we want. Essentially, we want to start 1 or 2 or 3 services within the same dyno. And that web concurrency will enable you to run multiple processes within a single dyno. So let's go take a look quickly. I think this is our cluster here. So I have an example here where I set up to a 3 cluster. Remember, we executed our first generated code. This is basically the same generated code, but adapted for clustering. If we run that again, hopefully, oh, wonderful. As demos go. Let's try that again. Maybe not. Maybe not today. All right, well, we'll skip the clustering demo then and move on because we have some more to cover today. So, but the idea is you would run multiple processes in there. So let's go back to our presentation and continue with our 12-factor journey. At number 9, we have disposability. To maximize your robustness with a fast startup and graceful shutdown, you don't want your application to fail when you're shutting down. And remember, when you're running on Heroku, the dynos may be started and restarted many times. And so you don't want any additional sort of problems with that. And we can easily scale that in that way. So architect your apps and build them so that they come up quickly and start handling traffic right away. That's what our customers want, rather than waiting for extended time. Development production parity. It's an important point to note. We want our testing environment, our production environment, our development environment sort of have parity of the same code base that we're testing and running with, simply because that's good practice. So with Heroku, we can easily achieve that by using pipelines. And Heroku Pipeline enables you to develop in one environment and then promote it easily to staging or to the production environment without any problem, just with a push of a button. You can also do that with the continuous integration and GitHub CI integration, or providing automatic push in deploy. But pipeline is one way of doing that as well. At number 11, we've got logs. Well, every server application, an API application, always produces logs. Think of logs as a stream of events that you're going to listen to as a heartbeat of your application. That will allow you to basically react onto different type of events that occur. You can listen to some crashes or some type of detrimental errors and react to it quickly by sending a message to somebody, by alerting an admin team that, hey, you need to restart this app, it's failing. And finally, at number 12, we got admin processes. We all love our admins, right? So we want to give them all the tools possible to manage these applications, especially in a complex environment. Heroku provides a wonderful dashboard that we're probably all familiar with. And it allows us to do all the functionality. However, we also want to have an ability to do command line. It's very important. And the reason is that you can automate the functionality at a very granular level, different functions of administrative activity by restarting an app or perhaps doing some type of updates to it via command line. And with Heroku, we have Toolbell that enables us to do that. There's not a parallel like that for mobile, unfortunately, but that's where we are. So with 12 factors, we're done with our factors. We've built an app, right? And we're going to move on further. Let's continue with our journey. Let's not do that. So while we were building our application, we have our mobile team that built a mobile app working with the UX group. And we have our Xcode project that was delivered. And we set up our environment to build our Swift code, right? So we've got, as I mentioned before, we've got our targets here, harvest dev, and harvest is for production, that we're going to be building with. Let's move over to the production API. So we're going to execute this target here on the production in a minute. But before we begin, if we do that right now and we deploy that to Heroku, we won't see much, right? And one of the reasons why is our data is static. We just hard-coded it. We haven't connected it to anything. And so here I wanted to introduce you the concept of real data real fast. And with Heroku, it makes even faster. So by introducing Heroku Connect, being an intermediary data synchronization tool between your Salesforce and your Postgres database, you seamlessly can move data back and forth. So Heroku Connect, if you haven't worked with it before, it could be a little bit confusing. Some people misunderstand it. Is it an ETL tool? Is it some kind of a service bus? Well, it's neither one of those. Heroku Connect is just a basic, very simple synchronization tool that enables you to move data bidirectionally between Salesforce and your database. And that enables you to do the very quick integrations with data. So let's go take a look at our demo here. So I have my Heroku environment. And hopefully, if network and everything cooperates, we can actually run this demo. So we've got, here's an example kind of tracking back. We got our pipeline here with staging, production environment. And we can promote it by using these buttons from one to another very easily. And here's our app. So we've deployed this Harvester API for Dreamforce. And we have our database resource with Postgres. We have our Heroku Connect and a paper trail. So here's an example of a paper trail where we see some examples of logs that we outputted. This tool also allows you to set up alerts in email or even Slack, different channels on what type of errors are there. There's different integrations available with that. Paper trail isn't the only one. There are a number of other add-ons that you could pick from Heroku elements. So there are many. It's a very large ecosystem of partners that provide those add-ons. So if we go into Heroku Connect, and remember, we were talking about things of harvest quota, right? We're talking about quotas delivering back and forth between our farmers and our processing plant. And with Heroku, we can see our database, what we've got in Salesforce. Now, while our team on Salesforce side have been hard at work, they build us these objects, right? We've got our object called harvest quota right here. And this object has some fields here that we want to map, right? Now, typically in ESB environment or some other kind of tools, you're going to have a whole development team working on this mapping. Here, it's just as simple as checking these boxes. And you just map the data. As soon as you save here, we already did that So once you authorize Heroku Connect to connect to your Salesforce, it will bring all that metadata on all these objects that you have access to, and you can map them easily. Once you've done that, you basically just sync up the data. And it will create automatically a Postgres table for you and start syncing data regardless whether it's 1 million records or whether that's 2 records. So let's go back to our Xcode. And let's run our app. And hopefully, if everything cooperates, we should be able to see some interesting results. Here we see our app starting, connecting. It's accessing a server. May take a little bit of time. And here we go. We got 82%. We're doing pretty good, right? So we're close to our end of our presentation as well. Now, this Heroku API allowed us to build this app so we can continue on iterating. This is not the end of it. We can continue building out our screens and moving on with building this application for our customer. Now let's go and summarize what we did and what we've just accomplished, right? So we have this architecture where we build a mobile app using Swift for iOS. We created API with Node.js. We connected these APIs with database on Postgres. We also used Heroku Connect to move data between Salesforce and Heroku and Postgres database on Heroku. And now you would ask a question, why do you need all this complexity when I could use something Salesforce 1 or Mobile SDK to connect directly to my Salesforce org and do somewhat similar? Well, certainly you can, but does it really make sense? So this architecture fits itself well to the massive scale and a public access. Now, the architecture that you see below, as an example there, has 2 major problems that you're going to have to deal with. One is licenses. You're going to have to give all billion people in China license in Salesforce. At the same time, you also have API limits. Imagine if your app scaled massively, what will happen to your org? Eventually, they'll stop responding. So that's a different approach on the mobile development. So now I'd like to just show you a couple of resources that I collected, something to keep in mind. The source code that I'm using here and showing available on GitHub, and all of the tools and environment that I was talking about are all outlined here. And all of these slides should be available for download. And also, if you have any further questions, you hit me on Twitter or also Chatter under that. On the agenda, there's a Chatter stream for this presentation. And so with that, I want to say thank you for coming to this mobile journey.